Hello everyone. In this video, I'm going to do examples related to angles property of a circle for you. In example 6, AC is the diameter of a circle. That means we should have some 90 degrees thing. And boy dot is equal to C dot. And AC dot is 25 degrees. And then let's look at the figure first. In the figure, there are 4 points on the circumference, and A dot is intersecting with AC. That means we may consider angles in the same segment. Together with that 90-degree thing, we can first consider this is actually 25 as well, and A boy C is 90 degree. And thus, it helps us find the angle of C boy dot, and also boy dot is equal to C dot. Boy dot is equal to C dot. So we have actually two angles being the same, and since 25 is given, this angle is known, then we can find this angle, and at last we can find angle boy dot C. Okay. So let's get started. So first of all, you may write down angle A boy C is 90 degrees first. Angle in semicircle. This is the first thing. Second, you may need to have angle A boy dot equals angle AC dot, which is the angles in the same segment. Then you know that angle A boy dot is 25 degrees. Now angle C boy dot is actually angle A boy C minus angle A boy dot. So you know it's 65 degrees. And then you can have angle C boy dot equals angle boy C dot, which is the base angles isosceles triangle. You can explicitly write down the size of angle boy C dot, and then at last you use angle sum of triangle to find angle boy dot C. So angle boy dot C plus angle C boy dot plus angle boy C dot is 180 degrees. Angle sum of triangle. Then you will have angle boy dot C equals 50 degrees. Okay, so this is example number 6. Now move on to the next example, example 7. In example 7, you are given two angles, angle boy AC and angle boy CF. And let's look at the figure first. In the figure, there are 1, 2, 3, 4, 5 points on the circle, which is more than 4, at least 4. So we may consider angle properties about 4 points, that is, angles in the same segment, and we may also consider opposite angle cyclic quad. And also there are some lines extended from cyclic quadrilaterals inside the circle. So you may also consider exterior angle cyclic quad. Now, in order to find angle CED, CED is actually one of the exterior angle of cyclic quad, which is the same as this angle, CAF. And now, note that A boy CF is another cyclic quad. Then the angle here 100 and the the opposite angles here, 32 plus this angle is together is 180 degrees. And thus we can find angle CED. Okay, so let's work it out. Number one, you may first have angle BOY AF plus angle BOY CF equals 180 degrees, which is the opposite angles cyclic chord. Now angle BOY AF is 32 degrees plus angle CAF plus 100 degrees equals 180 degrees. And thus angle CAF is 48 degrees. Next, angle CE dot is equal to angle CAF, which is exterior angle cyclic chord. And thus angle CE dot is 48 degrees. Okay? Now move on to example 8. In example 8, there's a diameter AB and O is given, and there's some angle lying outside the circle, and on the circle there are 4 points. But there are no intersection between the diagonals, so you may think of the opposite angles cyclic chord. Also, you may think of that since there is an extension of cyclic chord, so you may have exterior angle cyclic chord as well. And also you can see that point D is extended from the point A and B, so you have a 90 degree here. Now you should see that this 90 degree and the 20 degrees are part of the opposite angles, angle BOY AE and BOY dot E. So in order to complete the two opposite angles, you may assign an angle here, say X. Then, do you still remember when there's an angle outside the circle, we may need to use exterior angle of triangle to move it back inside the circle. So 30 degrees plus this X is actually here. And then we can use the opposite angles, the sum of opposite angles being 180 degrees to find the value of X, and hence find the angle A dot E. Okay, so let us write it out. Now, in geometry question, you can actually assign some angles as a variable to facilitate your working, but then try not to do it in the proof, but then you are allowed to use it when you are finding some angles or finding some length of a side. But then the letter should not be assigned to multiple angles, even for base angles isosceles triangle. Say for an example, if you have an isosceles triangle like this, you should assign different letters to different angles, but then you may say that X is equal to Y, and it is okay, but never assign the same angle A for different angles, although their sides are the same. Okay, so whenever you are talking about A, I don't know which angle you are referring to. Okay, so bear in mind this if you want to use this kind of small letter to represent angle. But then if you choose to write the original name, you are very welcome to do so. So what do we have here? We should have angle A dot BOY is 90 degrees, which is angle in semicircle. And next, we should have angle A dot E equals angle AC dot plus angle CA dot, which is exterior angle of triangle and angle A dot E is actually angle CA dot plus 30 degrees. And next, we consider the opposite angles. So we have angle boy AE plus angle boy dot E equals 180 degrees, which is the opposite angles cyclic quad. Now angle boy AE is 20 degrees plus angle CA dot, and boy dot E is actually 90 degrees plus angle CA dot plus 30 degrees. Then you can find that 2 of angle CA dot is actually 40 degrees and angle CA dot is 20 degrees. Okay, then you are asked to find angle A dot E. A dot E is this size plus 30 degrees. So angle A dot E is 20 plus 30 degrees, but then it's 50 at last. Okay, so that's all for example 8, and that's all for this video. We still have some examples coming up related to angles properties of a circle. Okay, stay tuned and thanks for watching.